Well, good evening and welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here at Kopernik. Um, I see a fair number of familiar faces, but who's here for the first time or not since your fourth grade field trip? Okay, this group right over here. Very good. Okay, who here are members? All right, almost everybody else. Great. Um, Kopernik Observatory, we are a nonprofit. We belong to what's called the ASTC, Association of Science and Technology Centers. It's a consortium of over 380 other science centers that honor each other's memberships. So besides getting into Kopernik on a Friday night or special events, you could go to Robeson Museum. You could go to the Corning Museum, Museum of Glass. You could go down to the Philadelphia uh, Franklin Institute or down in New York City for the Intrepid Museum. So if you like this kind of place, consider getting a membership. And our membership actually, a few years ago, I was taking one of my daughters down to the Franklin Institute, and had we paid the regular admission fee for just myself and my daughter, it would have been more than a year's membership here. So uh, it helps us out, and it helps you out, and especially if you got any summer plans uh, to you know go to some place interesting that might have a science center that's part of this ASTC program, um, consider getting a membership. So we've been around for over 50 years as a public observatory and informal STEM education facility. During the school year, we have school groups come up here. We take our resources out to schools to help their STEM engagement. During the summer, we have a very extensive summer camp program. In fact, just about 5 hours ago, we finished week 4 of our summer camps. We did a robotics camp here, and then a sort of a nature camp for younger students. Next week, we'll be doing Secrets of Code and a rocket camp. So this year we have 264 students signed up for over the 8-week period of time. We'll continue through the end of almost the end of August. But every Friday night from March to mid-December, we always do these programs. And it's really something I really enjoy doing because it's an opportunity for me to continue my education. We really are trying to promote lifelong learning, and not every program that we talk about here is about astronomy. And tonight's program, in fact, is a great example of that. So, but if you go to our website, it'll always tell you, what's coming up. So you'll see tonight's program on the next generation of electric buses and trucks. But if you go to experiences, and then you can go to our public programs, it'll tell you what's coming up. So that's tonight's program. Next week, we have sort of a preview of the Perseid meteor shower that's coming up in mid-August. We will be open in the middle of the week, clear only, and then we'll sort of do a following Friday. We'll try to hang on for a few more Perseid meteor viewing. Those will be a slightly later start, and then after that, on the 21st of August is sci-fi movies, The Good, the Bad, the Ugly, and this is Zoe Lerner-Ponterio, who works for Cornell's astronomy department. Will deviate slightly from her normal talk about what they do up at Cornell, and talk about sci-fi movies and what's like. Has anybody seen the Hail Mary Project? Fair number of you. People pretty much give that a big thumbs up. I remember watching the original Star Trek with Captain Kirk and all that, and there was one episode where Scotty had to flush nuclear waste through the ventilation system to get rid of ghosts in the computer. That's when they lost me. And but anyway, so we'll see what Zoe has to say. So one of the other things that's great about our programs is that we live stream everything. So if you actually go to our YouTube channel, you can see these are the programs that are coming up. Last Friday we did a talk on geocaching. We've had talks about underwater archaeology. We've had a high school group coming in talk about their competition robot. But along with our, what's also great about these live streams is that we're able to these for the last 6 years we've been doing this. So you could go back 6 years and see previous programs. In fact, I believe we may have even had. I'm not sure if we actually had. We had one of the hybrid buses up here a few years ago. That may have been. I'm not sure if that was live stream, but we'll have to go check. But one of the other things we also do is live stream observing. And so when there's a particular astronomical event of note, we will we'll do a live stream of that. And so here is actually a time lapse of the lunar eclipse that happened back in March of 2025. Most of you probably missed it because it started at 2 in the morning. This is a 1 minute time lapse. You see the penumbra start to cover the moon. And eventually, Jenny is also our live stream astronomer, and so she changed the exposure so we could start to see the light that's refracted through our atmosphere, that red light, that short, long wavelength light that gets through, and now we've got that blood moon. So this whole thing, I think, happened over about a 5-hour period of time, and just finished up just as dawn was starting to come up. So go to YouTube, type in Kopernik Observatory, and you'll be able to check out our programs. And if you're not able to come up here on a Friday night, you can actually watch us live on YouTube. There's actually people from around the world. There's often this woman from Adelaide, Australia, Lindsay, who will watch. So it's actually Saturday morning for her. So she's just finished breakfast and watches our programs. But as I said, we're not going to watch that. So these Friday night programs really are very enlightening. We've had people from Binghamton University coming here. We've had other local companies come and talk about the work that they do. We've had people zoom in from NASA, from literally around the world, talking about their particular interest in STEM. So tonight, though, we are going to focus on a local company, BAE Systems, who has really made a mark in the hybrid and electric vehicle market. And so we're actually going to start outside. So we're going to actually ask everybody to stand up. We're going to walk outside. The people on the live stream should be able to watch us as well. And Derek from BAE Systems will give us a tour. Then we'll come back in here and we'll get the rest of the presentation. I'm sure no one see that.
Okay, we're coming out.
Perfect. You have Venus as a companion. First object of the night.
Yeah.
Yeah, yeah.
No, I said I wonder.
Hey, how are you? Good night.
Man, they're still coming. There's more. But wait, there's more.
Yeah. It's your account.
Yeah. Who knew? Who'd have thunk it?
Yeah. Yeah. Oh.
Okay.
Right. So Derek, could you introduce yourself
Yeah.
And the truck?
Yep. Not a problem. I'll jump up here so I can see and be seen better. Well, good evening, everyone. We're here, as they said, from BAE Systems. We have, in the past, come up with a hybrid bus, and tonight we chose to come up with a pure electric truck. So we've been in the business of doing large electric vehicles for almost 30 years. We've got quite a number of them out there, over 20,000 vehicles out there, mostly transit buses. There's some even here locally in Binghamton. There's 6 hybrids here that are our systems. But this is a kind of a new one for us, doing pure electric, so it's not a hybrid, it's just a battery. I was mentioning to someone it's basically a really big golf cart. There's a set of batteries, there's an electric motor, and there's a throttle. There's other things going on, but that's the simplest terms. So this is our EV converted truck. It was a diesel when we purchased it. We then took everything out that was diesel required that we didn't need, and then built it back up with an electric powertrain. So it's got a set of batteries underneath those fancy looking steps. All the required accessories like air conditioning, air brakes, power steering, all that's pretty much where it was underneath the hood. But that's all that's under the hood. The engine's gone, transmission's gone. And then tucked in at the back is a small, by comparison, electric motor with a 4-speed transmission. And that's what drives the wheels. So we do regen. So it's rear-wheel drive, but we get full regen, so we can recover under braking. We do the electric braking, and at some point, if we have to, we can get into the foundation brakes. So this was built to showcase our technology, showcase our system, take it to OEMs who are doing electric trucks and say, well, now that you've done electric truck, let's show you how we do it. And kind of get our name out there, because although we're quite well known in the bus industry, bus and truck are different worlds. It's like cars and boats, really. They're very different. So we've had to basically start from scratch, building up our reputation to the truck space. And this is our calling card. We've taken this to most of the major OEMs in North America, the Daimlers and the Volvos and the Packars, Kenworth, Peterbilt, and allowed them to take it and drive it, give it a whirl. We've had it at a test track with Eaton, who's our partner for the transmission, and invited everyone to come to the test track so they could do whatever they wanted on the test track, because it's closed circuit, it's nice and safe. We've had it now for 3 years, and since we've converted it, we've just coming up on almost 5,000 miles. The first question everybody always says is, how far does it go? So it's about, on the highway is the worst. There's not much regen going on. You don't recover anything. It's just dead loss. We get about 150 miles, and then you're looking for a charger. If you're driving around town where you're stop and start and you're putting out energy, then you're pulling it back in under braking, about 180 miles. So that's typical with electrics, and with hybrids, you'll see city driving is better than highway driving. So that's about what it gets. The intention and what you're seeing trucks is mostly around town. They make a lot of sense in town. They like the acceleration for merging into traffic in city streets. They don't go a lot of distance, and it makes a lot of sense. They return to a depot at night where they can charge them. So this kind of truck would be like an Olam's delivery truck. Goes out and dropping off, beds and stoves and microwaves and things. Gets packed up the night before, does a day's worth of work around town, probably doesn't even go 100 miles, and then comes back home. And someone was asking, what do people like about it? I can tell you from all the drivers in it, they love how quiet it is, because there's not the big rumble and shake and noise of the diesel. And they love the fact that it's quite sporty by comparison. There's no turbo lag, there's no spooling up and all the noise that you get and all the gears it has to go through in the intersection. It just gets up and goes. So whereas the truck itself would have had a 6 or even a 12 speed, this has got 4, and we pretty much only use 2 unless you're getting out in the highway. Or you're loaded up and coming up the hill to Kopernik. And then we use first gear. Right now we're sitting at about 28,000 pounds, so 14 tons. On the back, the payload right now on it is about 14,000 pounds, 7 tons of payload. It's good to go up to 33,000 pounds. So this is a class 7 truck. So that's the basics. So questions?
Did the payload rating change when you changed it to electric?
Yes. So typically with electrics, you lose payload. One of our calling cards about this one is There is a company called Freightliner, which is what this is, that makes almost the exact same truck. And with the same amount of batteries on it that we have, they lose about 3,500 pounds of payload, which is just money. That's how you make money with a truck, is you move things. So they really don't like the fact that electrics weigh more. That's the battery. That's the way it is. The difference with ours is we've done a lot of consolidation of components. We have 2 boxes to basically run everything. And we only took a 1,200 pound penalty hit. So we did lose a little bit of payload, but less than everybody else. Any other questions? So go ahead.
How fast can it do 0 to 60?
So 0 to 60 is glacial. We pretty much, what they really like to know is 0 to 30, because that's where around town, that's what they're really trying to hit. So 0 to 60 is about 60 seconds. Yeah. I will tell you this though, it's faster than the diesel. The real snap is off the line with the torque that it has from an electric motor, which is instantaneous. So the 0 to 30 is where you really notice it. Whereas the diesels are 0 to 30 is about 30 seconds. This one does 0 to 30 in about 18 seconds. So noticeably quicker, which some of the fleets complain that they think they're going to be burning through tires, which is probably true.
How much of a degrading in the winter do you see in the range?
It's not good, that's for sure. Between heating and air conditioning, heating is the worst. Some of the electric buses have even been given exemptions to use fuel-fired heaters because 50% of the energy can go into the heater on a bus. That's, you got this huge empty space, the doors are opening all the time, people like to be warm. That's worse. This is not nearly as bad. We probably take about a 20% hit from in the wintertime, or if you do what I do, I just don't put the heater on. I'll defrost the windows and then I'll run it cold.
You should invest in heated seats.
Yes, yes, yes.
How long does it take to charge? Fully charge?
That really depends on the charger. So if you get a big enough charger, it's a lot of the chargers now are about 350 kilowatts. When we first started this, 200 was it. So you were an hour and a half, 2 hours. Now you're about an hour or less, maybe 45 minutes. That's if you're empty. You do not want the range anxiety that goes with a 33,000 pound truck running dead on the road. So did it once, I'm not gonna do it again. So usually it's charged in less than an hour. Yeah, sometimes half an hour.
How much is the cost savings like for diesel versus
Yeah.
kilowatt hours? How much you're really saving?
Where do you fill up is the question. So if you go down to Love's and they got a charging station there and you fill up, you probably are a philanthropic kind of person because you are paying about twice as much for the electricity than you would for the diesel. You will not save money. Maybe on wear and tear and maintenance. Now, if you do it back at your own shop and you're paying for it, you're much better off. But if you go around and use a public charger, they're typically running, at least the heavy duty ones for this, are running 50 to 60 cents a kilowatt hour, which works out to about $9 to $10 a gallon. So that's not a moneymaker. I'm really surprised when I see people at public chargers. I ask them, did you ever do the math on that? How come you don't charge at home? Well, my husband doesn't like me charging at home or whatever. He doesn't like to see the meter spinning on the side of the house. I'm like, you'd be a lot better off at home. 12 cents versus 50 cents.
Night rate's cheaper too.
Yeah. So you're not saving with an electric truck at this point if you have to fill up at stations. Now, if you can return to base with the day truck like this, where you would come back, well, then it's actually it's about half price for the fuel, equivalent energy.
Okay, can I suggest that we go in, have the formal presentation, but also I'm sure other questions will pop up, and we're fewer mosquitoes inside than out here.
No, I'm under the mosquito light. There's nothing.
You are. All right, thanks, Derek.
Yep.
I can also take the microphone. We'll have the other one inside. Thank you.
Yeah.
Oh, I know.
Derek or Ty want to. Okay, now we're back inside. For those watching on the live stream, thank you for that little pause here. But I think you were able to get a good sense of what went on outside. So, John, I'll let you introduce yourself and the program. You just go that area there and you're good.
Thanks. Thanks, Drew. Good evening, everybody. I'm John Hroncich with BAE Systems. I'm the Director for North America Transit Sales. Really appreciate everybody coming out tonight. My wife told me not to try to sell you a bus, which is going to be hard for me because that's what I do. But I am going to, since I'm in sales, I have goodies. There's a bag of these pens. Feel free on the way out to pick one up. I call it a MacGyver pen because it has a screwdriver in the top and it has a level in it, and it's both Phillips and flathead. So please feel free to take one on the way out. I won't give them to you now because then you'll play with the pen and not listen. But there won't be a test. I don't want you to worry about that. So you saw the truck. The truck is really the culmination of over 30 years of what BAE Systems and Endicott, and prior to that in Johnson City. If you're familiar with our story, right? Back in 2011, our Johnson City facility got flooded and we moved to higher ground over on the old IBM campus. But the technology you saw in that really evolved in the 90s when we started playing with buses. And before we started playing with buses, we were working on aircraft, both military and commercial aircraft. So the ability to control aircraft engines and manage power across the cockpit, the wings, and the tail of aircraft. Somebody before my time at BAE said, hey, let's see what we can do on a bus. And like Derek said, we are going to truck shows, we're talking to truck manufacturers. And back in the 90s, we were doing the same thing in the bus market. Today, right, we have established ourselves. I'm going to talk mostly about buses, but what you saw on the truck is really relevant and comes from what we do on buses. And please, you know, I'm not trying to sell you anything. This isn't really a testing environment. If you have questions, please stop. What I was hoping to do today is just shed a light on what's going on in Endicott, right? Because I think you'll be surprised of the amount of technology happening there, the places our products end up in across the globe, who are we working with, and then what are we doing next? So talking to Drew, we're going to spend maybe 20, 25 minutes and then take questions as we go. So, I put together just a couple of, I thought, interesting facts. We've been in this market for 30 years and have fielded over 20,000 systems. Most of those are on buses, but we've also done electrified military platforms. There's a platform called the Paladin. A couple years back, it was parked. We had to get it over the railroad tracks over in Endicott and park it. It looks like a giant tank. Um, it's actually built in York, Pennsylvania, but the components you see in the truck where the engine used to be, very similar to what we do on that platform, where we're managing power on. It's actually a self-propelled howitzer. So we're working in military markets. We're working in the bus market. We're getting into truck. We've actually done maritime applications. There is a completely zero emission ferry service in San Francisco. It's called the Sea Change. It's a fully zero emission electrified platform that has components from here in Endicott. We have 1,300 employees. 2/3 of those are either engineering or operations. Like I'm an odd duck. I'm in sales. So as you drive by the Endicott campus, most of the people you see there are either highly technical engineering or operations personnel. And we also do production. So it's another thing I think people don't realize. There's high-tech production going on in different buildings in that old IBM campus. And we host customers from around the world. Any given week, we have suppliers from China. We have fleets from Europe. We have component manufacturers from South America and then across all 50 states coming into Endicott, working with our engineers, working with our supply chain team to help us make new product. I'm going to show a couple of pictures of, again, I thought interesting where our products are ending up. That's Bryce Harper. Anybody know who he is? Plays for the Phillies. He did a promo. The transit agency is called SEPTA. It's the Philadelphia Transit System. They did a promo for the All-Star game. The sneakers somehow affiliated with the transit agency, but they put them up on one of our buses. That's downtown Philadelphia City Hall. So just kind of interesting. We have 360 hybrid buses running in Philly. If you go to Yosemite, the hybrid buses that run the shuttle service in Yosemite, that's El Capitan in the background, or Half Dome. Those are BAE product, again, from Endicott. During the World Cup, we had over 4,000 buses across, I think it was 18 different cities. That's actually in Vancouver. They stuck a giant soccer ball in the front of it to promote the World Cup. And then right here in Broome County, I took that picture in here because if you're into buses, you're a budding bus enthusiast, the best way to spot a hybrid bus, other than the words hybrid electric, is that bump on the roof. That's where the battery sits. Like Derek described on the truck, the buses are below the cab. On buses, we put our batteries up on the roof. Double deckers in London, hybrid buses. The challenge with that was they said, no, you're not going to ruin the iconic silhouette of our double deckers. So if you ever go on to a hybrid bus in London and sit up on the top floor in the back seat, you're sitting on a battery. That bus on the top right is from a company called Solaris. We work with them. They're in Europe. That bus operates in Romania. And we have buses in 16 different countries in Europe. The one on the bottom left is an iconic, really, our launch fleet in New York City. That's an Orion 7 hybrid bus. There's still a few of them running. They're probably 16 years old now. They were built in upstate New York in Oriskany. That plant has actually shuttered a few years back. But New York City has fielded over 2,200 BAE product hybrid buses and battery electric buses. So just like we have a battery electric truck outside, we're doing battery electric buses. That's a photo from Quebec City. Very challenging environment. There's some snow on the ground. The bus looks nice and clean. By the end of the day, it doesn't look like that. But we've proven ourselves in the toughest of duty cycle environments. We have about 1,000 battery buses now in service versus about 18,000 hybrid buses. So what we really do, and I hope that some of you, were impressed with, we make the components, but we also integrate the system. So while we're playing on trucks and we're doing things on buses, we're here at Kopernik on the Artemis II spacecraft. BAE Systems did all the phase array antennas. Now that wasn't here in Endicott, but those were BAE Systems products. So all the data and voice communications back and forth from the spacecraft were going through components made by BAE. There's a picture of the Paladin on the left side there, the third one down. On the top, you'll see some components we do in aircraft. Our heritage, everything we do in Endicott really harkens back to our business in aircraft, which continues today. Here in Endicott, we actually make our own circuit boards. It's not something that's really visible to, as you drive around the Endicott campus, but there is a building there with BAE designed circuit boards feeding different elements of BAE across the US. I'll talk more about the bottom right. That's new. We're getting into the vertical lift aircraft market. These are zero emission and hybrid electric aircraft. Just back on May 6th, we opened up a new facility here in Endicott. I'll talk more about that. But again, it's kind of a lineage, right, from old to new, and the platforms we're working on. I figured everyone here is somewhat of a data geek, and they like to see numbers. This chart represents the penetration rates of different powertrains in the bus market. So the line in the middle is, to the left, are actuals, and then the line to the right are BAE forecasts. Disclaimer, so someone taking a picture of it. This is John Hroncich's perspective on life. Like, don't go buying BAE stock based on this or whatever. But this is how we track the market. So on the top line are diesel buses. You'll see over, from 2015, they've been bouncing around a little bit over half the market. So every other bus in the market is a diesel bus. And that, frankly, is what I go after, right? I'm going after diesels. They're the most polluting, the most inefficient vehicle out in the market. So the more I can take from there, whether it's a hybrid or a battery or a fuel cell bus, that's a good thing for BAE. You can see this line here are natural gas, CNG, natural gas buses. Natural gas buses work great. They require their own infrastructure. We've seen that build out of natural gas infrastructure kind of wane over the last few years. So they've kind of flattened out. I don't think it's going to go away, but I don't think it's growing either. And then you see the, what I call the hybrid, the green line, and the battery electric. We've been predicting this crossover, right? Hybrids got the lead. They were bouncing around 10, 15, 20% of the market. And as the battery electric market really started taking off, the hybrid market, they were taking some from hybrids, taking some from diesel. So we predict that both hybrids and battery electric buses have legs, but eventually battery electric buses will be the relevant technology and hybrids will decline. And on the very bottom are fuel cell electric buses. Anybody familiar with a fuel cell? You probably heard about fuel cell cars. They use hydrogen, very much like CNG, natural gas. They require infrastructure. You have to have a hydrogen station, you have to have hydrogen delivered, or you generate hydrogen. So there's really a massive infrastructure that's going to take time, just like charging infrastructure takes time for battery buses. Viable, BAE works in the hydrogen market. We have about 3 dozen hydrogen buses, fairly expensive, but they work, right? I mean, they work in hot environments, cold environments, steep grades. It's just really the infrastructure that I think is holding that back. But it's proven technology. So we expect that over time to start taking some market share as well. And then what are we thinking about, right? What are the markets we're looking at? So we look at platforms, right? We looked at bus as a platform. We looked at truck as a platform. The things on the left are things we've done already. What's the future, right? Is it agriculture? We get customers saying, I work in a mine and there's no ventilation. How do I get rid of diesel fumes, right? That'd be perfect for an electrified system. but then you have to charge it, right? And then, you're digging a hole in the ground. There's not a charger right down, so there's all sorts of challenges. But as the technology and the batteries get better and they get smaller and more energy dense, maybe those types of platforms make sense. Garbage trucks. We actually had Derek and others at BAE worked on a hybrid garbage truck. Heavy vehicles, they require additional power for compacting garbage. Again, one of those payload questions, right? Like the truck's purpose is to haul garbage, not batteries. So there's, pros and cons in that area. But you kind of see the components on the right are some of those we make, some of those we work with, right? So we work with fuel cells. We don't make those at BAE, but we manage the power that comes out of a fuel cell. So as system integrators, we really try to right size the system for the application. Over time, our product line has evolved. The inverters you see in the first two columns are made right here in Endicott. The batteries that you see over here are for our hybrid platforms. Those are also made here in Endicott. And then the traction motors, we delivered this as a full, complete, integrated system to our vehicle manufacturers, which is unique because other companies supply just the battery or just a type of inverter or just the motor. And now you have like disparate components that you're trying to work with. And essentially what we do is across all these components, we also have software teams that are controlling all the things on the truck, right? That's really where the magic happens. I know Derek's not a software guy, but I think that's really where one of our strengths is, right? How do we manage power across these components and keep squeezing efficiency out of the system? Any questions so far? I'm going to talk a little bit about the next chart here, just about what's coming next. Okay. So back on May 6th, we opened up a new facility in Endicott. The plan, and it started already, is to hire 130 new hires. So it's a significant investment by both BAE Systems and with some tax assistance from New York State. Really leveraging the battery work we do, like you see on the truck, like you see on our buses, all the learnings, all the intellectual property we've built up over the years. How do we take that and make aircraft safe? I think about batteries, like if you fly, you hear the announcement, don't put batteries in the overhead compartment, make sure it's not in your check-in luggage and all that. Well, we're actually going to fly these planes with batteries. So imagine the certifications we have to go through with the FAA to certify that these are safe and reliable. Once you're 30,000 feet in the air, right, there's no backup engine, it's batteries. The other challenge is on a bus, our engineers are like, don't worry about weight, it's going on the roof of the bus. Well, for an aircraft, weight is a big problem, right? So we can't do what we've done in the bus market, right? And just, weight is almost like an afterthought in the bus market. Weight's a critical design element when it comes to aircraft. And then how they use these aircraft, all the power really is getting it up in the air and then controlling it on the way down. Once it's up in the air, the battery usage is actually kind of light. But so much different than a bus, like in a truck where you're pushing power back in and out of the battery kind of consistently. It's really the takeoff and landing requirements, these batteries, so they have to be able to push out a bunch of power really fast. So there's different chemistries involved, there's different design elements, and then finally safety. Can't have a fire, right? You can't have what they call thermal runaway when the aircraft is thousands of feet in the air. So how do you control a singular cell inside a pack if it goes into thermal runaway, right? If that one cell starts overreacting, overheating, typically it's a chain event that it starts affecting the cells adjacent to it. That can't happen on an aircraft. So that's really the focus of the FAA, right? Preventing that That's a lot where our intellectual property and engineering work is going into today. So this is happening in Endicott. It's the old building 258 over, I think it's the Russian Club. Is that over there? In, I forget the name of the street now, but Oak Street. So as you drive by, you see the front of the building on the left, that's all going on inside of that. So it's exciting. And again, it kind of comes full circle, right? I described how in the 90s, we took what we did in aircraft and brought it to rolling vehicles like buses and trucks. And then we're taking a lot of that expertise and plowing it back into the next generation of aircraft. Any questions or about what I talked about or about the pens or anything or?
If you have questions, just let me know because I want to bring the microphone so that the people in the live stream can hear. I'll get started.
Sure.
With the full electric vehicles, what sort of a charging connection is it? Sort of like a NACS or a CCS, or sort of what you would otherwise see for a regular electric car?
So a CCS 1 or 2 is typically it. So combination charger. The new standard that they're starting to come out is MCS, megawatt charging. So they're not as prevalent yet. So we're doing CCS on all of our stuff, typically between 200 kilowatts and 350 kilowatt charging rates. So we can't use the small 1772s, the ones that you use for your cars. That's too small. But pretty much wherever you find those, you'll find a couple of the commercial grade ones.
Like my, I happen to have an Ioniq 5, and which has the fast charge. The beyond the 1722 has those 2 other DC connections, and so being able to actually charge at 200, 300, it's amazing how quickly you can charge a battery.
Yeah, and what we see in the bus market are overhead charges, right? So catenaries that come down, what they refer to as opportunity charging. So charges on bus routes. You see these in Montreal. So as you're at a bus stop, people are coming and going. The overhead charging will descend onto the bus, top it off, right? Gives you a little bit more range. It's challenging because I remember they tried this in New York City, and every time you move a mailbox in New York City, there's all sorts of permits and things and red tape. And so imagine trying to put the transformers and the infrastructure in to support a charger. So there's challenges to that, but that's also another way to make a bus run longer, charging it en route.
All right. Any other questions? We have a couple. Good. We have a couple. Oh, actually, we'll start right here.
In Switzerland, we rode on an electric train. Are you thinking of developing train technology as well?
Yeah, I mean, there's electric trains and then there's trolley buses. Sometimes the trolley buses you see them in Philadelphia and in Seattle. They basically have a catenary on them and they run on overhead wires. Very similar to an electric train, right? There's no diesel engine. They're hooked, or it slides along the line. But and then now what they're starting to do is have batteries so they can go off catenary and transit a part of town just on the battery. So we are working in those areas, right? It's very similar technology, right? We like to think of ourselves as agnostic to where the power comes from. So whether it's a fuel cell or batteries or a hybrid engine or a catenary, right? The management of the power can use all the components we have today. In the U.S., frankly, in Canada, there's not as much of it as you see in Europe.
All right. Other questions? All right. Everyone here.
I'm a retired chemist, and
Oh boy.
okay.
I'm a history major,
So,
well, go easy on me.
No, one of the things that I'm very interested in, and I believe that weight is an issue, even with surface vehicles. I own some hybrid cars, but what work is being done on new battery materials? For example, I have difficulty. I'm 84 years old. I have difficulty with my 56 Chevy putting a battery in it, the old lead battery, because it weighs so much.
Right.
And is any research being done on battery materials to make them lighter?
Yeah, the one thing I can say that I see BAE working on is the casing, right? Not just the cells and trying not to have propagation, but how they're packaged. So the packaging material, we see that that's an area of opportunity. And then the actual enclosure that the batteries seems to be, I don't know if Derek and Ty want to talk, where a lot of the weight effort is happening.
All right, got a couple.
There's a lot of work going on with the weight. It is coming down to a lot of the packaging. Once you try to put all the batteries together and they have to be held in a structure, that adds a lot of weight. There used to be cells were then put into modules. Modules were then put into packs. Now they have what they call cell to pack. So the module part of it's gone. The cell and the pack basically get put together as one. So that was a savings. But chemistry wise, they're doing a lot of work with the chemistry, trying to come up with lighter weight materials, solid state to get rid of electrolyte. Liquid is heavy. So getting rid of the liquids is one of the big things that Advantages has. So you may hear about solid state batteries. And that's one that does help a lot with weight, but it is a big deal. He's not wrong. And as I said out there, payload is everything for a lot of these guys. So they do not want to carry around dead weight in the battery.
Any other questions? I'm back here.
I know you said that the electric truck is much quieter than its diesel burning counterpart. For these aircraft, how much of the sound it produces comes from the fuel it's burning versus just the sound of the rotors?
It'd be very similar to the truck, because there is no fuel on these aircraft. There's a tremendous amount of thrust to get these aircraft up in the air. So the majority of the sound is the rotors. I'm gonna be honest with you, I haven't actually seen this. They did a demo just last week at the Farnborough Air Show, where they took an aircraft to 30,000 feet. And what I've heard was when it worked, they were able to prove it could go up and come down. But I really haven't heard much about how much noise is it creating. It's a good question. But like I said, there's no engine, so it's not like aircraft. Like when you sit on an aircraft and you take off.
All right, any other questions? Oh, here we go.
So like the batteries for the buses, like how long do they take to charge?
So that's a great question, because this gets into the life of a bus. And buses are great applications because they come home every night. Like trucks are hard because they're on the road and they're looking up where the next charger is. So the challenge we have with transit agencies is I bring my bus in, I fuel it in 10 minutes, and then I park it. And then the next morning it has to go out. So typically a bus has like a 6 to 8 hour window to fully charge. They can charge faster, but that requires more infrastructure. So 6 to 8 hours is like the average for a transit bus. School buses are even a little more different, right? Because a school bus does its work in the morning and then really doesn't do much, from first period to ninth period, and then it has to go back out again. So what we're finding in the school bus market for fully electric school buses is that they're getting away with a smaller battery pack, and they only need like a 4-hour charge, and they can charge more at night. But they do their work, they get a 4-hour charge, and then they go back out. So a lot of it's what we call duty cycle dependent. It's like, how is the vehicle being used?
Any other questions? All right.
Especially for the trucks or vehicles that might get out on the highway, do you think much about optimizing the aerodynamics? Because that's the exact same shape as a Freightliner diesel, which is basically not aerodynamic?
Yeah, that's a good question. I mean, that we retrofitted that truck from a diesel truck. So that truck is not was not intended to show off aerodynamics. I think when you see some of the designs of like Tesla and Derek and maybe Ty have seen, you know, they are designing a truck from the ground up, right, to maximize efficiency from aerodynamics. Yeah, but that truck, yeah, probably not a good example of aerodynamics, especially with the big blocks sitting on the back of it. And but efficiency, and like Derek said, you know, you turn on the heat, you start losing range, you start our little knack is how do we manage kilowatts? So the inverters out here are using silicon carbide switches, which is the latest switching technology, and essentially are rated at 98% efficiency. So if you have 100 kilowatt hours on the bus, you know, we only lose 2 kilowatt hours in pushing all that energy around, driving, running accessories. So, you know, we're not designing the truck or the bus and the frame and the, you know, the surface area. We're trying to manage the power, right? Some of those accessories need a little bit of power and they kind of ramp up and they ramp down. They don't want, you know, a full wave of power. So how do we feed those accessory systems to give them just what they need to come up and down most efficient? That's where our team and the software team, frankly, spends a lot of time.
Another question?
Do you think there would be additional gains from changing the drivetrain? Because right now you have I think a 4-speed transmission going to a drive shaft, going to a rear differential. There's a lot of gears in there, including adjustable gears, and a lot of EVs try to have a very short drivetrain, basically just with a fixed reduction. And I wonder if you might try to do that.
Yeah, I'm going to turn over to Derek, but I mean, I know it's an issue of torque as well, right?
Yeah, so our the buses that he was showing, our buses have morphed from fixed ratio. So there was a gear reduction in them. The motor spun at about 10 to 11,000 RPM. They had to come down to about 2 going into the rear axle. When we went to trucks, the problem we had with trucks is, unlike cars, they have a lot of weight and they have to go fast. With a bus, they're a lot of weight, but the buses are typically very slow. Like a fast bus, they're usually governed to 60 miles an hour. And once they hit service, they often take them down to like 40 miles an hour. So the problem we have with trucks is making the torque and going fast. You can do it. But one of the things that people are doing now, sort of along those lines, is they're starting to look at integrating the motors into the axle itself to get rid of the prop shaft. So there's no drive shaft in there. Pros and cons to that. There's then what they wind up doing is they put on very powerful motors that spin fast to make power, but then there's a lot more gears. So efficiency then takes a hit because you got so much gear reduction. Although this one has gears, it only has 4, and they're low speed. So it's fairly efficient from that perspective. I always tell people there's 2 ways to make torque. You can make it with copper and current, or you can make it with gears. And so far, gears are usually more efficient and a lot more cost effective and a lot smaller than trying to make it with copper and current. Copper's heavy, current's expensive. So you have to put 1,000 amps through something. Everything's got to handle 1,000 amps. That's expensive and heavy, a lot of copper. If you can do it at 300 amps and just use a gearbox, that tends to be more efficient. So it's a trade-off and it really depends. That's why cars get away with it. They're not that heavy and they don't need to go that fast. So they can do it with usually direct drive. We've done buses with direct drive because they don't have to go fast. But when we got into trucks and you have to do both, then we needed at least a couple gears.
Well, one of the issues that you're dealing with is electrical charge. So right now, your limiting factor appears to be the time it takes to recharge batteries. Okay. Cars get around it by hybridizing.
Mm-hmm.
So is your R&D pointed toward transitioning with hybrid vehicles? Because I noticed some of your your buses are hybrids.
Yep.
Okay, but your truck is not. Is there a problem with hybridizing?
No. I mean, we go to trade shows all the,
Where's your R&D?
yeah. So
Where are your R&D bucks going?
we have a foot in both, on both pedals, right? We have,
Okay.
so we're still investing in hybrid. We're still investing in zero emission, including fuel cell, right? So the beauty of what we call a series architecture, right? So we took the transmission out, just like with this truck, right? We gutted a bus. We took the transmission out in the 90s and replaced it with a motor and created a platform. It's called a series architecture because it's an electric motor based. Where we get the power from doesn't matter. So we can do hybrid buses with a diesel generator. We can do battery electric buses with the same configuration, just feeding our electric motor with batteries, or a fuel cell. So it's a great question because this is my life. Like, I'll go to a customer, hey, I want to do battery buses today. And in a year from now, they say, well, you know what? It's really expensive. It doesn't meet my operational needs, like what you're saying. Like the bus goes out and only does 100 miles. I need to do 200. Or it doesn't, we don't have the on route charging set up. So some customers are coming back to hybrid. Hybrids are great, and I'm getting into sales mode. I got to watch myself here. Hybrids are great because you can drop them off at Broome County Transit. They don't need any chargers. They learn on the hybrid all the things you do on a hybrid bus with high voltage and safety and maintenance and diagnosing and troubleshooting, all those skills. By the way, you got a bunch of elder diesel mechanics out there, right? I don't want to say old, but you have all these diesel mechanics. They're learning these skills now.
Highly experienced.
Right. Highly experienced, right? Veteran diesel mechanic. But a hybrid lets them play with diesels still a little longer. But then they start to, deal with orange cables and, electric motors. And really they don't realize it, but they're learning everything they need to do to run a fully electric vehicle like that truck.
Yeah, your experience with taking your vehicle to a Love's,
right,
or on Elmira, and finding that 9 of 10 of the chargers don't work.
Charging, yes, there's issues. Chargers have to communicate with the vehicle, and yes, there are certainly growing pains with that.
Yeah.
But also for those of us with electric cars, I mean, when internal combustion engines started being mass produced, they didn't have gas stations every 3 or 4 miles on the highway, right? So you're seeing more and more charging stations, along major routes, and so I think like everything else, it's a process to get there. I also think the battery, research done on batteries, you're seeing now vehicles that have longer range for the same battery space, if you will, faster charging time. So yeah, I think there'll always be some compromise, but I think like any other technology, as you develop it, you start spending more time finding where do you need to really spend your intelligence on improving the overall experience for people. So another question.
Hopefully this isn't multi-part. What is the lifespan on the batteries used in the city buses?
So a bus is federally required to last 12 years, right? That's how long any train, and we see them last 12, 14, even 16 years. Typically one battery change over that time period. So, and it really depends on how they run them. We've seen batteries last up to 10 years, 6 years, somewhere in between. We also have this is getting way off, again, going into sales mode, an ultracapacitor solution, which is an old technology. It's as old as lead acid batteries. Ultracapacitors it's not a chemical like that wears out like lithium ion. So ultracapacitors last the life of the bus, and they're really good about power in, power out, power in, power, energy in, energy out, energy in, energy out. So that solution lasts the life of the bus. But our lithium-based solutions are designed, again, this is where software comes in, and manage to only have one swap out over the life of the vehicle.
So you might not actually have the answer to this question. I don't know if it's something that can be answered in just a couple of minutes either, but what does the sustainability look like for those lithium batteries compared to diesel over, let's say, a 50-year period? I know we don't have a lot of data to look back on, but when you're talking about sustainability and environmental impact, diesel, not a renewable resource, but neither is the material used to make a lithium ion battery. So what's really the trade here?
Yeah, that's a good question. The industry struggles with that, right? Like, what do we do with these batteries when we're done with them? There are companies and research efforts going on to recycle lithium batteries, right? Extract what you can, reuse the materials. There's second life applications like data centers that have used lithium batteries from other applications as backup power, right? So, or even like utility grid applications where you don't need the batteries all day long like you do on a bus. Like you just want to have stored energy, sits there, the lights go out, you can power, a substation or a data center. But yeah, I mean, I don't know how to answer like what's, right. One's burning fuel that doesn't come back, right? Like we don't have more dinosaur, fuel coming. But then lithium, right? I mean, there's only so much of it in the ground. What happens after that?
All right. Unless there's any other questions, John, if you want to hang for a little bit for.
Yeah, by the way, it's great to have all these questions. I know it's Friday night. It's great to have questions from the younger folks, and I really appreciate it. So thank you for the questions. They're great.
Well, thank you, John and Derek and Ty, for bringing the truck up. You have something to say, Jen?
I was just going to say, we recently attended a workshop with a bunch of think tank groups, and one of them was around sustainability and comparatively looking at all the different fuel types or energy sources. What was interesting is 3 different groups presented what was surprisingly aligning conclusions. Usually you don't get that. You get in there and somebody's like, hydrogen's the only solution. Another one's like, no, biodiesel's the only solution. No, electric's the only solution. What was interesting was 3 groups. We were one of them, and there were 2 more. We thought we were going to be disruptors. We were going to come in and tell everybody, we're going to rock their world. And the surprising thing was, from a sustainability aspect, for today's technology, at least where we're at today, and how we make things, how we make electricity, what the grid's quality is, where the cleanliness is, what the mining for natural gas and so on, what the environment is. The winner in all cases for all the different groups that came up was a biodiesel hybrid was the #1 best for the environment. It was actually the only one that was positive. All the other ones did damage. The biodiesel was the only one that was actually footprint net positive. And it was a little shocking. And then we thought, we're gonna rock this world. The other 2 groups presented before us, so then we look like copycats. But it was really interesting that they independently, and one of them was a government group, EPRI, which is all about trying to encourage the use of electricity. And they came and said, well, we got to be honest. This is what the data shows today. The cleanest thing you can do for the environment is a biodiesel hybrid.
All right. Thank you. Thank you. Well, again, thank you all for coming. First of all, again, thank you, John and Ty and Derek, for bringing the truck up and telling us about all the great work that's being done just down the hill. A couple things for those that are here. If you look off to your left, there's that extraordinary quilt, and that is a quilt that actually the wife of one of our board members was able to pull together, and this is actually being raffled off at our Astrofest, which will be September 18th and 19th. Tickets are $5 per ticket, or you can get 5 tickets for $20. Also, believe it or not, there is a solar eclipse coming up in 12 days. On August 12th, there'll be a solar eclipse. Now, totality starts in Greenland, goes through Iceland, and ends in Portugal. But we actually will see a very small portion of that, up to 10%. Here in Binghamton, about 10% of the sun will be covered. We actually still have some eclipse glasses. So if you have your eclipse glasses, make sure that they're not scratched and use them. But if you would like to purchase eclipse glasses, we have them at the store for $5, and very strongly suggest that you don't look at the sun without those glasses. Also, I'll point out, you don't put those glasses on and then take your binoculars and then look up, because very soon what will happen is within a second that those binoculars, that the sun's energy that's being concentrated because of those binoculars will burn straight through that film. So you can only use those glasses by themselves without anything else. We invite you to come outside. We'll see what we can have some of our scopes to look at. We'll do a star tour, and it's a extraordinarily beautiful night here tonight. So we should be able to see the Milky Way and probably some satellites. And so thanks again. And next week will be a preview of the Perseid meteor showers. And we actually may catch a couple of Perseids tonight here as well. So thanks again, and we'll see you hopefully next week.
Thanks, Drew. It was a lot of fun.